Okay, domain and range. Here's how you do it. So, domain is what can x be? So what are all the values? What are all the possible values for x? And what can y be? What are all the possible values for y? So if we look at a graph, let's say we had a parabola with its vertex at 3, 1, and it's opening up. There's our parabola. We want to say the domain and the range. So for domain, we would look at all of the possible x values that the graph can be. So right here, the x value is 3. Over here, it's 4. Over here, it's 5. Here, it's 2. Here, it's 1. And so on. It's going to keep going. And as you can see by these arrows, it's just going to keep going up and up in both directions forever and ever. So we know that eventually it can be anything. So we say that, we write that like this, XER, which just tells us that x can be anything, really. But what it means is x is an element of the set of real numbers. So it can be any real number. Okay, and then if we look at range, so now we're looking at the y-axis, and we want to know what are the possible values that y can be. So we look at the axes, and we're like, okay, there's 0, 1, 2, -1. So when I look down here at -1, I don't see how the graph will ever reach -1. Here at y equals 0, it's never hitting. Here at 1, there is a point, and at 2, there's a couple of points. So, and it's going to keep going up. So I would say the lowest value is 1, and there's nothing below it. So therefore, y has to be greater than or equal to 1. And that's how we would say domain and range. Let's try another one. Okay, so say we had the graph of a square root function, a radical function, and it's starting here at -3 and it's heading this way. So we want to comment on what the domain is. So we're going to look at the x-axis and we're going to see, okay, what are all the possible values of x? So here x is -3. When x is -2, it would have a point. When x is -1, there would be a point. When x is 0, be here, 1, and so on. It keeps going. But here at -4, the graph was never getting here. So I would say for domain that x has to be greater than or equal to -3. And for range, I'm going to look at my y-axis. And see, okay, what are all the possible values for y? So I'm looking this way. So I can see that at 1, oh cool, there's a value. At 0, oh yeah, it starts there. At -1, I don't see anything down here. So I'd say my range is y has to be greater than or equal to 0. Okay, one more. Okay, let's just say we have like a random graph, a random function. Maybe we don't really know what it is, but we'll just graph it and it's going to look like, wait, timeout. Sorry. I'm pretty good at trying these. Alright, let's do something like this. Let's go over and down. Okay, so there's some random graph. So if we want to know what the domain of this graph is, we're looking at the x-axis. So we're looking along here, and we're thinking, okay, along the x-axis, looks like 1, 2, 3, 4. -4 is the farthest it goes, then there's nothing here. And 1, 2, 3, 4, 5. is the farthest over. It goes this way, and there's nothing over here. So I would say the domain has to be between -4 and 5. So I'm going to write that as x has to be greater than or equal to -4 and less than or equal to 5. So I would start with my smaller one, my bigger value, put x in the middle, and then use my greater than, less than signs to indicate. And then my range, I'm looking at the y values, and I'm trying to see, like, I think the tallest part of my graph is here at 2. There's nothing else up here. So +2 seems to be the biggest. And then the lowest part of my graph seems to be here at -1, and there's nothing else down here. So my range is going from -1 to 2. Put the y in the middle, and then I want to say it's greater than or equal to -1 and less than or equal to 2. And that's domain and range. Here's like a crazy one. If you try to find the domain and range of a reciprocal function, like let's just take y equals 1 over x, for example. So say we were graphing this, a reciprocal function. Well, all we know, like our x and y's can pretty much be anything because our graph's going on in both directions on the x-axis, except, I should highlight, this middle part here at, x equals 0, that's our asymptote. There's no values there. So if we want to find the domain, I'm not sure the exact perfect notation, but maybe we want to say, you know what, x is a real number, but such that x can't equal -1, maybe, something like that. So x can be anything except it does not equal 1. I meant, oh my gosh, I put 1. I meant 0. I'm crazy. Okay, so the domain x can be anything except for 0, really. That's what that's saying. And then y is going to be similar. So we have another asymptote right here, and that's right at y equals 0. We have an asymptote. So that's just saying the graph's approaching that value, but never getting it. Well, it can be almost anything, but it can't be 0. So we would just write it like that. That's a crazy one.